Hi there, my name is Isaac Oster. I am a character and technical artist in the game dev industry. And I typically will, if I'm not just making regular old character art, I tend to focus on writing tools using Python and Maya that make painful parts of the production process a little bit less painful, hopefully. And so a common thing that we run into all the time is when we've got a high poly model and we would like to get that high poly model in game so that our, the designers can take a look at it, kick the tires on it, or maybe we want to unblock the animation team from building the rig or whatever happens to be. There's just a lot of reasons why you might want to get from your finished high poly to a gamer's asset without going through the entire process of properly retopologizing it and doing the UVs and the bakes and all that kind of stuff. So what I have done here is basically built a fairly simple pipeline using Houdini that takes care of a lot of that process, and it has a little bit of flexibility. I'm a new user, so it's not the fanciest thing in the whole world, but I thought there's enough information in the Houdini thing that it's probably worth just going over, and if anybody has any questions or whatever, I probably can't answer them, but I might be able to point you in the right direction. So I wanted to go through and just review the Houdini digital asset and all of the little features and stuff therein. So let's get to that right now. So this is the HDA. This is what you would see if you were a user, and I've got some things here exposed already. Let me go ahead and pull out of that the view there. So this is the geometry, and there's all kinds of different states of the geometry being rendered right now, and so it's not really the prettiest thing. But what I have, so with the Zbrush file, there's a bunch of different subtools, and each one has a unique name. And what I would like to happen is I don't even want to go through the process of assigning material ID colors in Zbrush. I want to take care of everything outside of exporting the FBX in Houdini. So if we jump in here, I have several nodes that take care of different components of the process of creating a low poly asset. So the first thing is I need to figure out a way to get access to the names of these objects. So if you, I guess with this guy, let me jump in here. If I go to my little selection tool here and I say, I would like to use the name attribute, you can see I've got access here to all of the different names. So what I'm going to want to do is create a little bit of Python that will allow me to assign a material ID to each one of these independently. And then by material ID, I mean a material ID color, which is a vertex color. And then I'm going to basically dynamesh, or in this case, voxelize each piece individually. Let me go ahead and escape the selection option. And then reduce that mesh, and then run the UVs on it, and then bake it out. So some of those controls are exposed here. Probably if I was using this in an actual production, I would want to expose a few more things, because at this point it is a little bit limited, but it's good enough for testing and learning and teaching. So let's just jump right in here. So again, we are looking at this HDA. I dive in, and my first thing here is going to be gather mesh names. It's just a geometry node. And I'm going to go ahead and import the geometry. This is the Zbrush FBX, which is kind of talking to this field right there. And then I just smooth all the normals on it. There's some stuff here with the way the geometry was created using like booleans. It looks fine in Zbrush, but you do get some weird little artifacting. I wonder if I just sculpted on accident. You get some weird little artifacting kind of on these edges. If I turn on the wireframe, you can kind of see it's got some nasty little triangles and stuff on there that Zbrush doesn't care about, but you might get a weird little issue when you bake. This is a very quick and dirty bake, so probably not really that big of a deal, but whatever, it's cheap and easy, so we'll throw it in there. And then I have this this assemble node, and if I hop over to my geometry spreadsheet, kind of see, go to the primitives. So if I'm up here, you can see this is what the geo comes in with, and it's not terrible. It's completely fine. But if I throw the this assemble node on there, it'll automatically. I think I just need to tell it like. I might not even really need to tell it anything. I think these might be default settings, but it'll go ahead and just clean up the names, right? But what we can see here is there's lots and lots and lots of different primitives and many duplicates of the same value. So I need to get basically just one instance of piece 43 and one instance of piece 44 or whatever. So, but this is the first step, is we'll go ahead and clean up the names, and then I have this attribute wrangle node. And it's worth mentioning at this point that I watched two incredibly useful tutorial series on YouTube. One of them is Indie Pixel's Python in Houdini series, which is wonderful and explains a lot of this stuff in more detail than I'm going to go into here. But and then the other one was Michael Pavlovich's Houdini tutorial, which goes through kind of the voxelization and UV and poly reduction phase of the tutorial. So I would recommend both of those very, very highly, and you'll get kind of more information. But with this simple expression here, I can create in my detail tab let me go ahead and select it, basically an array, a list here of each unique name that is associated with the high poly. And it's cutting off because, like, whatever, I don't have that much space here, but it goes on for many, many, many entries. I think there's over 200 subtools. I could be wrong, but there's a bunch of them. Now, but anyway, so now I've got this names array that lives in the geometry. Again, we've got our little geometry spreadsheet here. So this is all stuff I can access via Python. So that pops us out of the gather mesh names, which again is just going to basically generate, it's going to clean the geo up with that normal node, and then yeah, just go ahead and deliver us this this concise list of all of the objects that are associated with that FBX geo. So the next thing that I got to do is come over here to apply color, and I will briefly show you kind of what's going on here. And it is a great big series of things that are all created procedurally with Python code, and I'll show you that code in just a minute. But before I do, I just kind of want to show you what the Python code is doing because it's easier to sort of see it in this context. I create an object merge node, and into that I feed my gather mesh names. So again, if I pop out of here and we look at gather mesh names, what this is going to be spitting out is all of the, basically it's just the cleaned up high poly geometry. So if I hop back over to, whoops, too far, to my apply color node, I'm importing gather mesh names, which is the cleaned up high poly, and then the group that I want to talk to specifically is, in this case, piece 136. And I already showed you how we found that value, and I'll show you in a minute how we apply it. And then I create a color node, and I feed it some values that are unique to this node. And then I plug all of those things here into a merge node, which basically puts the high poly back together. And then I've got a little output here. So the way the outputs work is if I want to refer to the gather mesh names, if there's an output that everything feeds into, it'll, like, I don't have to specify a node inside gather mesh names. I can just say gather mesh names and it'll reach down to the output. So that's pretty convenient. So that's how apply color works. And this basically will give us our high poly that has material IDs assigned to it. Looks like I might have misplaced my geo somewhere. Right, okay. So this is what the end result looks like. It's just our lightly polished high poly geometry, and now it just has vertex colors. And each vertex color is generated automatically with the Python code, and the network that assigns it is also built using Python, and that's all good and well there. So once that process is done, I head over to the reduction. And let me just go ahead and scoot this up a little bit. We get a little bit more room here. So again, we've got an object merge node, and I'm just importing gather mesh names, but now I don't need to worry so much about, and maybe I do want some of this space up here. I don't need to worry about specifying, turn off template. I don't have to worry about specifying a specific piece because I want to deal with everything. And I wonder if I can scoot this guy down. Right, so you can see here in my group field is empty because I want everything. And if I were to grab this dropdown, you can see, oh my gosh, there's all these pieces. There are so many. All right, so this little chunk of code here is a for loop. It is a node-based for loop, and this one is the value that it uses to iterate over is the name. So for each named primitive that I'm feeding in here, I will do the following steps. So this is going to be a voxelization. So this is going to basically, it's a Dynamesh if you're familiar with it. It just gives us a dense, clean version of the geometry where I don't have those nasty edge triangles. Then that's like a special kind of geo, and you got to convert it to polygons. So that's what this one does. So for each item, each individual named piece here, the first thing I do is I basically Dynamesh it, and that's a Zbrush term, so Houdini calls it voxelization. And then I convert it back into polygons. But when I do that, I lose my name, and I really need the name. So I go ahead and throw my little name thing here, and let's see, attribute copy. Maybe I have to select it. Right, so this is just copying the attribute name from above the out operation. So this is where it's coming in, and then where it's spitting back out, I'm just going to throw that name back on there, and then there are little for each loop ends. So what this gives us is basically a dynameshed version of the geometry, the high poly geo, and it still remembers its name. From there, I have a poly reduce, which is just like a standard issue poly reduce. There's nothing fancy there, not too much anyway. And that value, this percent to keep, is actually exposed here in the main HDA UI. And then I've got a fuse, which is just like a merge in Maya. It's just going to collapse the close edges. And I've also got this vertex merge distance here is exposed as well. You can see there that snap distance. I just renamed it so it's a little bit easier to understand. And then I've got another normal operation just to smooth everything out. And then an auto UVs. And if I activate this, you can see here are all of my UVs on my low poly, all generated automatically. And then it is necessary, it'll have a bunch of different material names on it, and in order for it to work in Painter, it's all got to be on the same material. So there's this quick material here, and I just put that in so that everybody's sitting on the same material, and then I've got my little output node. So that gives me my low poly, right? And then in my Baker, it's pretty straightforward. I have to apply a material, a Houdini material to the high poly, which is coming in on this side, in order for the Baker to kind of do its calculations. And then the low, it's another object merge, and I'm just grabbing reduction, which is the group that we just left. It's this one right here. So Baker just takes the low poly and the high poly, which will look very familiar, and then it's got some settings here, some of which are exposed. So I've got my resolution, and then I know that I'm just going to want all of these maps. So it'll also spit out the a bunch of other ones, but these are the ones that I want. And the reason I'm not using position here is because I prefer to generate position inside Painter. You don't actually need to you don't need the high poly for this. And I think it's a 16-bit TIFF inside Painter, and you can't actually import 16-bit images into Painter. So in order to get the right values, I just like to do that one in Substance Painter. So once that's done, it's going to automatically spit out all of the maps at the resolution that's exposed here in the UI, and then it'll also output the FBX. So we get the reduced low poly FBX, and all of its UVs here are included as well. And this is what the end result looks like. I'll just show you here in Photoshop. So it's pretty good. This one, this is a reduction of down to 2% of its starting count after the voxelization process. And so we've got 115K tries. That's probably a little bit too much. But then, if we go to 1%, we get 55K tries. And if we go to 0.5%, we get 27K tries. And for something like this, imagine how many different pieces there are, and there's a lot of internal surfaces. It would, this could be a thing that is as complicated as a vehicle or something, right? So 27K tries for a vehicle, that's not too bad, right? And we're losing a little bit of fidelity here in the nostril. But again, if we're looking at it from kind of far away, it's not a big deal. So here's that mid-level version, the 55K version, and if I apply some materials to it, I think it looks okay. Again, the goal here is not to make a finished asset, although you probably could apply the same workflow to something like a photogrammetry asset or something. But just to get something in game so that your downstream people are unblocked by waiting for you to lovingly retopologize your model by hand and then do all the UVs and all the rest of that stuff. So if I want to generate an asset using this pipeline, all I have to do is import the high poly, set what percent to keep, and this is an interactive thing. I mean, it's not all that interactive with a piece of geometry this dense, but it probably takes 3 or 4 minutes to kind of run through the whole pipeline. And then you set your map resolution and go ahead and hit this, and it'll spit it out. So I do want to briefly go over what the Python looks like and how that's set up, because it is kind of an important part. I talked about how we gather the mesh names, but I did not talk about how we set up all of these nodes here procedurally. So to do that, all you got to do, if you want to access your Python, I guess this is off the recording space, but there's a menu option here called type properties, and once you've converted this to an HDA, you can get to that. In fact, you can get to the type properties for just about anything, but the HDA is specifically designed to be edited that way. So these parameters here are what the end user is going to see up in this section here. And you can either create them from over here and then pipe in whatever you want in terms of the functionality, or you can drag them directly from the UI. Like if I wanted, I could drag guest from group in and put it someplace, and then that the end user would have access to that. So it's incredibly flexible and super easy to use. But I have this button here called Process High Poly Geo, and what that's going to do is it's basically going to build this apply color node with all the stuff inside. And there's this little command here that is very, very useful, which is basically just hou.pwd and then a little open and close parens, and then HDA module, and then apply RGB, and then as the argument to that function, we pipe in hou.pwd. So very, very quickly, what this means is this is basically the HDA. This is the Python module that lives on the HDA, and then this is the function that is in the Python module. And you can have any number of functions in the Python module. In my case, I've only got one, and you can see it right here in the scripts tab. And here is my apply RGB function. And so the first thing that I need to do is get the attribute wrangle node, because that's where my name array lives. And then there's some commands here that you can use to get the data off of the geometry attribute and into a list in here in Python that you can then use to iterate over. And then I go ahead and, because you want to generate new geo whenever you add a new high poly, this will basically go through everything that is in the output geo node, which is this guy right here, and it will just delete anything that's in there. This is a little bit of Python code that will generate a fairly decent sized list of all of the 3-value combinations of the numbers in this list. This is basically, it's called a list comprehension, and it's basically a shorthand for 3 nested for loops, if you're familiar with for loops, but not list comprehension. A very, very useful thing to play with Python there. And then, because the first value is going to be 000, that's not really a valid material ID color. So I want to go ahead and just remove it. I could probably remove the last one too. I don't think I actually got to the last one, but that would not be a bad idea. So then this is all going to go in there and basically create this little node network of each piece. So the first thing is we're going to go ahead and let me just zoom in. So I'm going to create an object merge node, which is this guy here, and I'm going to go ahead and name it whatever the group is. So you can see piece 149. And then I am going to set some parameters on it. I'm going to set the object path to point at gather mesh names, which is my node 1 generation up here, which is just going to spit out the geometry. That basically the high poly cleaned up geometry. Probably gather mesh names is not the right name for it. I should probably call it like cleaned up high poly, but anyway, here we are. So that's the input geo, and then for the group, all I want is whatever the name happens to be. So I'm only going to be talking to that one group within my high poly. And then I'm going to create a color node, which is this guy right here. I'm going to set the RGB values of that color to whatever happens to be in my list for, whatever iteration through my names I happen to be. And then all of that stuff is going to get merged down into my merge node using this set next input function with a color node as the argument, which is created right up here. Actually, I guess it's created a little bit higher when I build the node, but that refers to each object merge's child color node there. And then once all that stuff gets put together in the merge, we apply an output and set the output render flag and display flag to on. I don't probably need the render flag. I'm not really rendering anything here, but I didn't really understand that when I was creating this. I think I have a little bit of a better understanding of that one tiny facet since I wrote this code. But that is how the code works. And so basically, whenever the user inputs new geometry, if they press this process high poly over here, it is going to go ahead and call my apply RGB function. And this HOU-PWD, that's basically just referring to the HDA. That's just like, so in the script, the argument I use is actually parent. And then I can kind of speak to parent. I don't even know if I'm using parent. Anyway, doesn't really matter. Probably this line does the trick. I could probably get rid of parent. So that is the Python code. If you know Python, it's probably not that crazy. If you don't know Python, it probably does not look like something that you want to jump into right away, but it's actually pretty straightforward. Again, I would check out the Python in Houdini tutorial series by IndiePixel. And all of the stuff over here in the Baker section, this is, well, sorry, not the Baker section, Baker and reduction. This is mostly gleaned from Michael Pavlovich's excellent Houdini tutorial. So that is the general workflow. And again, you know, if somebody comes along, they import their high poly, they press process high poly, and then once that's done, that process just builds out the supply color and grabs the list of names. Then they can just hit bake maps and export low poly FBX, and they will be presented with an FBX mesh with UVs and all of the mesh maps that they would then need to bring into Substance Painter and plug in, and then yeah, you're just ready to go. So it works, and I think that's pretty cool. And I think Houdini is pretty cool too. So it is a little bit complicated, but you know, if somebody's there to kind of break down the steps in more detail than I did, then it's definitely doable. And if you've got somebody who can answer your questions, special thanks to Ben House, who also has a wide variety of his own Houdini tutorials on YouTube, can actually make some progress. So thank you very much. If you've got any questions, feel free to reach out in the comment section or try to shoot me an email, and I'll do my very best to get you sorted. Thanks.